During this short video tutorial, I will cover the conventions for naming and writing formulas for covalent compounds. Some important things to remember from previous information: covalent compounds share electrons, so the bonds are formed through sharing. They consist of two or more nonmetals. The nonmetals are found on the right side of your periodic table. So anytime there are two nonmetals bonded together, we call that covalent compound. And unlike the ionic compounds, which have a very specific ratio in the formulas that they can create, covalent compounds have multiple forms. So we could see nitrogen and fluorine bonding together in more than one way, whereas sodium and chlorine for an ionic compound can only bond in one specific way. Alright, some conventions for naming. These go along with your notes. Remember that the subscript equals the prefix, so we're going to use prefixes when naming covalent compounds. We are going to eliminate mono as a first name. So we will not use the prefix mono when writing the first name. We will not have a double O at any point in our name. And then we will always change the last name so that it ends in IDE. You have a prefix table on the back of your periodic table. It's more inclusive. It goes up to 10, so make sure you're using that when you complete your assignments. In our table, it shows you the number of atoms and then the prefix that we will use for that number. So when we look at our first example, we have 1 carbon. Number 1 is mono, but we just learned that we do not use mono as part of the first name. So we're just going to write carbon as our first name. Looking at our second name, we see that there are 4 chlorine atoms. So we look at our prefix table, we find 4, and we see that it's tetra. And because we're looking at the last name, we know that it must end in IDE, so chlorine becomes chloride. So our last name in total will be tetrachloride. So CCl4 is carbon tetrachloride. Notice that I did put a space between carbon and tetrachloride, but there is no space between tetra and chloride. Tetra is a prefix, but it is part of that second name. Looking at our second example, we have arsenic, and there are 2 of them. Our prefix table tells us that the 2 is di, and then we do not change the name of the first element, so it stays arsenic. Then we look at oxygen. There are 3, so we see that that is tri, and oxygen becomes oxide. We have 1 carbon again. We don't use mono for a first name, so it becomes carbon. And then we see that there is 1 oxygen, so we know it's got to be mono. But remember, oxygen starts with an O, and we're not going to have 2 O's next to one another. So we're going to drop one of those, and it becomes monoxide. You see how there's just the 1 O there. And then we have sulfur. There's only 1, so we don't write mono. And then there are 2 oxygens, so dioxide. All right. There is our quick example of naming. We're going to reverse this process for writing formulas. So we're going to identify the element and then follow that element by the number that the prefix stands for. So we see that it's disulfur. So your di is 2. So we know that there's sulfur, which is S, and there are 2 of them. And then trioxide, oxide is O, tri is 3. Dinitrogen, so that means there are 2 nitrogens, and we write that N2. And then monoxide means we have 1 oxygen, so we write that O, and then it's a 1, but we don't write ones. So phosphorus means there is 1 phosphorus, so we're just going to write the symbol. And then pentachloride, we see that penta is 5. So there are 5 chlorines, so we'd write that Cl5. Now look at this chlorine gas. I didn't really talk about the diatomics, but they are listed in your notes. The diatomic molecules are the Hofbrinkel twins. These are the ones that will be found bonded to something in nature. They do not like to be alone, so they will always bond to something, even if that means they're bonding to an element identical to itself. So anytime you see chlorine gas, or chlorine gas, or fluorine gas, or oxygen gas, notice those are all ending in the word gas, and that just means that there are 2 of them present because they are a diatomic, di meaning 2. Now you guys, you might also see that it's like Beyonce. It's just the first name. So you might see it as chlorine gas, but you could also, which remember I just said it was this, but you could also see it as dichlorine, as if I was just writing the first name of a compound. So dichlorine or dihydrogen or dibromine. So there is our quick and dirty video for writing covalent compound formulas and naming them. Thank you, and I will talk to you soon.